I'm Adam Hayner, Juniper Hill Farm. We're a certified organic operation in northern New York. We do about anywhere from 60 to 80 acres of certified organic mixed vegetables. A lot of those mixed vegetables are transplanted, obviously, as well as direct seeded. We use a variety of trays here, primarily 128s, 200s, and for some of the larger seeded crops, 50s and 72s. We use a landmark tray. In the course of a year, we would have to be doing at least 6,000 to 7,000 trays.
So I know one of the steps you've taken to improve the labor efficiency of the seeding process is to use a tray filler. So maybe we can go over and see what that piece of equipment looks like.
This is an older model Bolden and Lawson flat filler. I don't really know what they cost brand new. This was used from a New Jersey greenhouse. I paid about $1,000 for this many moons ago. It is indispensable tool on the farm. We can fill hundreds of trays very quickly. There are several adjustments depending on if you're filling a 50 flat or a 128 or a 200, and it takes about 5 minutes in between flats to adjust what you need. You know, the amount of moisture in the soil and different variables, but it's all pretty simple. Essentially just different adjustments for the tray height. Once again, this is really designed for 10-20 flats, even though I think some of the PropTech flats and everything would likely be able to run through it. It can't fit a Speedling flat. So here is a standard 128 flat. So something we do in the field that saves us a lot of time because there's so much transplanting is when guys empty flats, they're required to make sure all the soil is out of the flats, and we stagger the flats so we're not putting them right back in one another, and that makes it a lot easier at this step in the process with how much we're recycling flats. I didn't take all the time to set this up as I perhaps would. There's a little nuances if we were running 100 trays. Usually we run, if we have a lot of trays to fill, we run 2 people. One person working hard can get both of these done. We like to unstack the trays and have a pile of them, and then we have another pile where the finished trays are. So in this case, there was a little extra soil that was on top because it's not perfectly adjusted, but with some adjustment you essentially get a perfectly clean and level tray, which then allows us to move on to the dibbling. We will show you the dibbling process now. This is a homemade dibbler, a homemade with a 3D printer. We'd be happy to share the 3D printer file with anybody that wants to make one. There are companies that make them. We 3D printed one because I think they wanted $600 for each one, and I think this is probably $20 or $30 worth of material. I think this was a 22-hour print time on this one. We have different dibblers for each tray size, a 128 or a 200. Oftentimes we have a hose here for misting. A series of trays will be misted depending, once again, on the soil moisture. We notice that if the moisture is too high, it sticks to the dibbler, and we just dibble down the tray, and when the soil moisture is right, there's a very nice triangle generated. And that triangle, I feel, is important because it allows the vacuum seeder to end up with the multi-seeded plugs right in the middle of the tray, opposed to having some growing out of the side. And we also use a vacuum seeder for pelleted seed that allows the Salanova to be right in the center. And from there we move on to the seeding machine. This seeding machine is called a Niagara seeder. They're made out in Niagara, Ontario, I believe. I purchased this used for about $2,000. They do exist every now and then used. Brand new, I do believe they are run upwards of $10,000 to $12,000. This is a vacuum seeder. It can do multi-seed cells. It can seed 604s, 128s, 50s. It can seed pretty much any cell size up to a 512, and it has really been a considerable time savings. The one limiting factor, the manufacturer of this machine says it can do pelleted seed. I have not had good luck with pelleted seed because if you get the adjustments wrong, it smashes the pellet, and then the pellet gets sucked up into the vacuum. This operates on a laser, and why I said the PropTech trays and the Winstrip trays are problematic is because these trays, the laser indexes where the cell is. And so the laser has to look through the cell. So it is possible to buy things that allow speedling trays and other trays to be used with this machine. It just requires you to put every tray on another board. So this, once again, primarily works really well with standard 1020 trays. Today we're seeding bunching onion seed. There is different size nozzles depending on the size of your seed. There's 0.06, 0.12, and 0.24. In this case, with a bunching onion, we tend to seed with a 0.012. Here we are starting the conveyor. There's a vibrator for the seed, and then there's the vacuum pump. There's multiple adjustments on here depending on the seed. And here we're doing a single seed. You can also change it. In this case, normally a bunching onion, we would do 2 to 3 seeds per cell. So it'll cycle 2 times per plug. And then it will reach the vermiculite topper. We use extra fine vermiculite, and the vermiculite dispenser is adjustable. I've never actually clocked how many trays an hour we can do, but it is less than a tray a minute for sure. It's like a tray every 15, 20 seconds, and all the person here has to do is pretty much watch this, the amount of seed in it. There is some maintenance with the nozzles. You know, I like to keep some 3-in-1 oil around to lube them, and you can get a clogged nozzle every now and then, but it does not happen much when you're attentive. And if you really need 1 seed per hole for certain crops, if you take the time to adjust it, like if you're doing tomatoes with it, you can make it have 1 seed per, but sometimes it can be a little fussy. We really love this for our wintergreen seedings. You know, a lot of tomatoes we actually do still seed by hand because we use larger 288 speedling trays for them. But every now and then we do 128s in our tomatoes. But once again, you know, with multi-seeded crops like beets, chard, sometimes certain chards are a little large for the nozzles, and because of the irregular shape of the seed, it's problematic. But if you have regular seed, you know, round seed, brassicas, it does extraordinarily well. Bunching onions well, our regular onion crop, it does very well. So one of the better investments I feel like we made in our propagation house was a tag printer. In this case, this, from my research, is the cheapest tag printer you can buy, and it prints on rolls of tags like this. In this case, we use a 4x7mm tag. That way it fits inside a 128 cell and still offers enough information. If you do retail pack sales, they make this tag in all sorts of different sizes, and the printer can be set up to print all sorts of different things. It's a thermal printer, so it uses a thermal ribbon. It can't do pictures and color, just primarily for words. Considering your alternative is handwriting thousands of tags, if you want to have the organization and the dates, you know, this was a very good choice. I think we're up around $300, and then we probably go through $100 in tags a year. And I am very strict in my fields about picking up the tags because it drives me crazy. Typically you'll have templates set up for your plant tag for the size and everything, and then you just type in what you need, change your date or whatever other information you'd like, and then so we do that with how many trays we need to seed. We actually keep these right at the coming out of the machine, so before misting we can put the tag in it and keep track of how many trays it is we needed. It's certainly taken probably 3 to 5 years to accumulate this process of how we do things, and there's certainly room for improvement, but we have a pretty high quality transplant going into the field. For the most part, this system has really worked for us.